students. So far we discussed the computer instructions last class. Then we discussed the computer registers. The computer registers is a memory, a temporary memory the equivalent to your processor. So your any computer having many registers like here you have a DR register, data register, address register, and accumulator. You have instruction registers, PC program counter, TR temporary register, input register, and output registers. So those are the register and the bits it will hold, and the function, what would be the function it will perform. Today in this section we are going to see the basic computer of a basic control unit of a basic computer. Okay, in this section.
Basically, for timing and controlling the computer, we require control unit, and that is what is control organization. Now, this control unit can be designed by means of two ways. Number one is hardware control. It is basically implemented by means of gates, flip-flops, decoders, and digital circuits. Now, to have the fast mode of operation, it can be optimized very easily. So, we can get the faster results. If we want to do any kind of changes to this control unit, then we need to do the changes in its wiring, which is done between the components. So it is somewhat complex for us to modify. Then the next organization what we are having is microprogram control. Now in microprogram control, the control information is stored into the control memory. That means this control memory is one kind of ROM wherein all the informations are stored for the controlling part. And the control memory is such a program to initiate the required sequence of micro operations. That means if you want to perform addition operation, then the required sequence for performing addition is stored into the control memory. And if we want to do any kind of changes to this operations, micro operations, then we need to modify the control memory's information. So it is easier rather than doing any kind of changes to the hardware organization. So both are having their plus and minus points. So in this session, we'll be discussing about hardware control organization of a basic computer. Let's see how it is implemented. But before moving to that, we need to have the revision of instruction register. Now instruction register, we are knowing that it is of 16 bits in a basic computer. So 0 to 11 bits are for the address for memory reference instruction, register operation for register reference instruction, and input output operation for IO instructions. Now 12 to 14 bits, that is 12, 13 and 14 bits are meant for opcode, and the 15th bit is meant for the I bit, which is I bit, it means for the direct or indirect addressing in case of memory reference instruction. Now that value is 0 for register reference instruction, and it is 1 for IO instruction. So let us see the designing of control unit. Now for that we require some control logic gates, but we need to give the input to this gate, so based on the control output we will be getting. So for that we require the sequence counter. Now why sequence counter? Because our computer works on some timing. That means we work on some time. As in our day-to-day life, we also work on some timetable. So same way the computer works on some time. So we need to provide the timing signals. So for that we require a 4-bit sequence counter whose 3 inputs are increment, clear and clock. Now because everything works on clock, so we need to provide the clock as an input, clear, so once the sequence counter, if you want to clear it in between, so we need to give the clear signal, and the increment, so we need to increment the counter every now and then, so for that we require increment signal. Now the output of this 4-bit sequence counter is given to the 4 to 16 decoder. So we will be getting 0 to 15. So we will be getting different timing cycles starting from T0 to T15. So in all 16 timing cycles we can obtain using 4-bit sequence counter SC. Now what happens is during this control organization, 0 to 11th bit of instruction register which you are seeing is directly given to the control logic gates. Now whereas 12 to 14 bits are decoded and they need to be given to 3 to 8 decoder which will generate the sequence from D0 to D7 based on the inputs given to the decoder. Now regarding the 15th bit of the instruction register, that is I bit, it is directly given to the control logic gates. Now this is the organization. Now there are certain other inputs are also given to the control logic gates. So that would be other inputs which we are not concerned at this moment. And the output what we are getting is control output. So based on this organization we will be getting some output. So this is the control unit of a basic computer. Now let's see one demo. In that case, suppose I am having a binary bit pattern to be this, which is stored in instruction register. So 15th bit, 12 to 14 bits and 0 to 11 bits. Now how computer will understand which instruction it is? Now by seeing this we came to know about which instruction it is. But how computer will understand? Let's see. So what happens is 0 to 11 bits, that means all these bits are given to the control input directly. But now opcode 001, that means it is given to the decoder and the decoder output based on 001 is D1. So based on this D1, computer control logic of a computer will decide that which instruction it is. That means as it is D1, so it will say at this time add instruction is to be performed. But again the question arises, add instruction, whether it is direct or indirect. The operand provided over here is direct or indirect. So we are knowing that it is decided based on 15th bit. So let's say we are providing it to be 0. That means it is direct instruction. So control unit will decide that based on this D1, it will understand that this is the AND operation is to be performed and corresponding control signals would be generated from here and they would be given to the corresponding registers and other parts of the system. So this is how the system is going to work. Let us take one more demo. That means D3, D4. Now this is a register transfer language. Now you all are knowing what is register transfer language. So if you interpret it, it means that when D3 is 1 and T4 is 1, that means both should be 1. At time D3 and T4 if both are 1, then sequence counter is to be made 0. That means it is to be cleared. So let's see into the form of waveforms. So this is our timing cycles. As you can see, clock T0, T1, T2, T3, T4 and so on. Now when this T0 occurs, so this is our timing cycle T0, T1, T2, T3. Now we said at time D3 and T4, that means if both these values are 1, so now this T4 is 1 now. But only T4 will not work. D3 should also be 1. So say for example D3 is also 1 now. So at this time, that means both are 1 now, that means at that time we need to send the clear signal to sequence counter. So we are saying clear signal is now 1. Initially it was 0. So now when D3 and T4 at both this peak, it will become 1. So clear signal would be 1 and the sequence counter will be made 0. This is how the control unit works.